So here's lesson 2.1. We're the first lesson of our second unit, and we're going to be talking about exponents and scientific notation. So these are the things that you can write down in your small notebook. So for exponents, we talked about this, and yeah, I'm sure most of you have seen exponents before. This is an exponent when you've got 5 squared, or 5 to the power of 2. The power is this little piece right here. And what we call the base is this piece. Okay, so you can take note of all these. So whenever you have an exponent, this is always the power, and this is what we call the base. Index form is when you see something like this, 3 to the power of 4. And expanded form is when you see 3 times 3 times 3 times 3. Okay, so we're going to be working with this idea a lot to discover the laws of exponents. So it's just good to know the difference. This is when it's in index form, and this is expanded form. Okay, a couple things to note. We had a look at the difference in class. We had a look at the difference between these two values. So we talked about how -7 squared might be different than -7 squared without brackets. And if you have brackets, this is going to be -7 times -7. Right? This is -7 times itself. And that will give us a positive 49. But when you have -7 squared without brackets, first by PEMDAS, oopsie, we have to do exponents before we do multiplication. So let me explain that to you. First, we have to look at 7 squared, which is 49. And this is sort of treated like multiplication, and it still has a negative in front of it. So this is actually going to be -49 for this one. So those are a little bit different. Just be careful when you're working with brackets today and for the practice problems and homework. Okay, and we also had a look, and we said, what do we notice here? So you can pause the video and have a look yourself. What you'll discover is that 4,300 can also be written like this. Okay, it's another way to write the number. It has the same exact value. It's just another way to write this number. Okay. My computer is being really slow right now. Sorry. Here we go. So this is another way to write 4,300, and we actually have a name for this. We call this scientific notation. So you can jot that down. In science, we often work with really big numbers when we're thinking about the mass of the sun or weighing really large objects, but we also think about really small numbers when we're looking at atoms and molecules. Okay, so we need to be able to measure those numbers without having to write tons of zeros. Okay, so this is what we call scientific notation. And if you pause it, maybe you notice it yourself. Basically, as a number, the decimal lies here. And if I go 1, 2, 3, that's always going to be the indice, okay, the power. All right, and in scientific notation, we always do one number, and then the decimal, and then another number. So this will become 4.3 times 10 to the power of 3. And that is equal to 4,300. This is equal to 4,300. This would be like having 4,300 euro. Okay, it's the same exact number, it just looks different. Okay, and so as you can see, the same thing here. We always put the decimal here after the first number. And then we count 1, 2, 3, 4, 5, and that becomes the indice. Okay, so the first value is always going to be a number between 1 and 10. Okay. And so you might notice a little bit of a difference here. This has got a negative. Well, that's because this is a really small number. So when it's positive, it's a really big number. And when it's negative, it's a really small number. Okay, so this is a very tiny object. And again, you've got the first number and then your decimal. And then we count from where the decimal actually is. 1, 2, 3, 4, 5. And I know this is a really small number, so it's -5. So you're going to be practicing going back and forth between these forms today. Yeah, and if you need some more help with this idea, there's 2 more videos below on my website. All right, good luck.